How you doing? We are in chapter 9 for water reuse. Um, and when we talk about um, technologies for dissolved constituents, we're talking about our TDS, right? Our minerals that will be left behind. So to simplify it in layman's terms is, that white stuff that's on your shower head or around your hot water tank. Um, you know, that is a good indication that you have water that has TDS in it. Now, we want some TDS in drinking water um, because it adds minerals into our bodies. So if you drink just pure RO water, you're not getting the minerals that your body needs. Um, but also, depending on what our use is, let's say we have a boiler that we are trying to use water reuse. Um, if we run water that is high in total dissolved solids through a boiler, we could possibly damage that boiler. So really, some of our options are, membrane filtration, or electrically ED removing it. So we'll talk about that when we talk about nano and reverse osmosis. Basically, we're talking close to the same thing. We're just really talking about the pore size, right? Um, but you know, like at our water plant, we don't need 100% reverse osmosis. So we use nanofiltration, right? The pore size is a little bit better. Reverse osmosis, you can actually, use that in seawater applications with a high enough pressure. On page 466, you can see different arrays that you have, and those are RO membranes. And in each one of those RO membranes, I'll say that there's actually 7 membranes in a tube. That's the way our plant is arrived. And we'll look at some of that. The other way that you can remove total dissolved solids is electrodialysis, and just using electrical current to making positive and negative, and then separating the ions that way. Um, so, one of your questions um, is the two membrane configurations that are used commonly are spiral round and hollow round fiber membranes. And so, depending on whatever application you need or what your pilot study determines, is what you may have. Um, you may actually have a reverse os or a microfiltration, ultrafiltration before your reverse osmosis or your nanofiltration. And the purpose of that is your micro and your UF are going to take out any large turbidity, and then your nano and reverse osmosis are going to take out those dissolved solids that are not readily um, in layman's terms, that you can't see by eye, or you know that would pass your standard TDS test through a um, through a pad. On page 470, you can see a typical membrane up to your left there. The water is fed on one side of that membrane off to the right there. And as it's pushed through, the permeate goes through the middle. And then as it works through different arrays, so you may have a whole set of um, nanofiltration RO units, and then the water from it will get put back into the beginning of another array, and that's really just to recover water. But what's important to realize with nanofiltration is you're always going to have a percentage that gets put to waste. And so if you have 100 gallons that go through your RO, typically you're going to have anywhere from 20 to 25 of that 100 actually will go to waste. And the reason why is it's carrying across those membrane arrays, it's carrying that reject water away. And one thing we need to know is where are we going to dump our reject water? So out of 100 gallons, 20 of that is going to be reject water, and it's going to carry, but it's going to be really high in TDS. And so it's really important to know what you're going to do with that. We at the city I work at, we dump that right before we discharge into the creek, and the EPA has us monitor that. Um, there's no sense taking that and putting it through the plant just because of pumping cost. But we discharge to the creek, and then we have to keep a tight eye on that. So like this time of year, I'm actually doing bioassay, so I have to take upstream samples and effluent samples in the wastewater treatment facility, and see how that water is really affecting our ecosystem. And so that's one thing we need to think about when we select our um, our unit. Typically, the way it works, one of the concerns you have to have is with membrane. You can actually question 13 489 organically foul. So you have to typically treat the influent water that goes before a nanofiltration unit. You have to treat it with some sort of chemical um, so that the membrane doesn't either scale up. And then you also have to make sure that you're not biofouling your membrane. If you have any kind of organics or biofouling or heavy iron on your nanofiltration, what's going to happen is you're going to blind um, um, that membrane. Okay, so that's why pre-treatment is important. The other thing that you want to remember with reverse osmosis is that water that's making it through those spiral membranes, it's very low in pH. And so you might have to add caustic soda or re-aerate the water before you can use it in your application, because you need to get the pH back up before you use it. So just some things. Uh, Periodically, you have to chemically clean the membranes. Um, I used to do that. Once again, it takes a special type of skill set. It takes a lot of maintenance, I believe, when you go into reverse osmosis, but that may be the application that you need. So let's talk about electrolysis. So it is a electrochemical separation process in which minerals, salts, and other ionic species are transported through ion selective membranes from one solution to another under the driving force of direct electrical potential. As compared to NF and RO, which transports pure water through the membrane, leaving salts behind, ED salt is gradually stripped from the solution, leaving a dilute solution which contains particulate matter and neutral species not removed by ED. And so you can kind of see on page 501, you're using a node and a cathode, and you're using electric to really separate those ion membranes. And so there are some electrodialysis um, uh, units there on page 504. Uh, Page 509, management of these waste streams, right? So you're going to have uh, water that's high concentration of TDS. How are you going to how are you going to manage those? What are you going to do with that water? What are the um, uh, economic impacts it's going to have? So your disposal options, you can subsurface inject it, you can discharge it to a wastewater collection system, you can put it to. I know in Iowa we had an evaporation pond where it can evaporate, but you can. You can landfill it. There's lots of different things that you can do with it, but you need to have that set up before you invest into the technology uh, for water reuse. I appreciate that. That's a quick review of Chapter 9. Thank you very much.